my channel Junior Sir. So guys, in today's video we'll discuss some steps that you must follow while doing the questions of factorization. So without wasting time, let's proceed. So before starting, let me explain you what is factorization and why do we use it. So factorization is the method or procedure which we use to simplify an algebraic or numerical expression, and because of factorization we can obtain our answer very quickly. So let us start with the steps. Number 1, to take common. Second, to take common by making pairs. Third, form of a plus b whole square, and this is equal to a square plus b square plus 2ab. Fourth, differential square form, and our last topic is form of ax square plus bx plus c. So let us move to our first step, which is to take common. Let me clean the board. To take common. For example, if our algebraic expression is like this: 15 m square plus 5. So if you carefully see, 5 can be taken common in this. So we take 5 as common, and taking common means to divide that term with the other terms. So by dividing 15m square by 5, we'll get 3m square, and by dividing plus 5 with 5, we get plus 1. So this is our answer. Second example. (16 p square plus 20 p cube plus 12 p raised to the power 4. So in this we can take 4 p square as common. So 4 p square we have taken common, and I have told you that taking a term common means to divide that term with the other terms. So if we divide 16p square with 4p square, we get 4 plus 20p cube by 4p square, we get 5p, and if we divide 12p raised to the power 4 by 4p square, we get 3p square, and this is our answer. So I hope you understand till step number 1. So let us move to our step 2, which is making suitable groups or pairs and take common. Then take common. For example, if our expression is like this: x a square plus y a square plus xc plus yc. So I told you that first you have to apply the step to take common. So now here you will stuck, because if you take x common, x is here and here but not there in these two terms. A square is common, a square is here and here but not there in these two terms. Y is here and here but not there in these two terms. So in this condition, what you will do, you will make pairs, suitable pairs. So this we can make a pair, and this, and we recognize a pair with underlining it. Now from this pair, a square can be taken common. So we take a square common, and x plus y will be left. And from this pair, we take c common, then x plus y will be left. Now x plus y and x plus y. We have two terms and x plus y is common. So we'll take x plus y as common and a square plus c will be left, and this is our answer. So this is making suitable groups or pairs and take common step. Another example. Now I am taking a little bit harder example. X raised to the power 5 plus x raised to the power 4 plus x cube plus x square. Now we'll apply the first rule, which is to take common. So the largest factor that can take in common in this is x square. So we'll take x square common, and from here we'll get x cube. From here we'll get x square, x plus 1. Then we'll make suitable groups. So we can make this group or this. Now we'll write it as it is, x square. Then we'll put a bigger bracket. Now we'll take the largest factor that can be taken common in this group is x square. So x square is taken common. Here we'll get x, and I told you taking common means to divide the term or factor with the other terms. So if we divide x square with x cube with x square, x will be left, and x square plus x square, 1 will be left. Here also the largest term that can be taken common is 1. So we will take 1 common, x plus 1 will be left. Now x plus 1, now we have two terms, x plus 1 and x square x plus 1 and plus 1 x plus 1. So x plus 1 and x plus 1 is common, so we will take x plus 1 as common. Then from here x square plus 1 will be left. Now we will break the bigger bracket. X plus 1 and x plus 1, and this is our answer, x square plus 1, and this is our answer. Now our third step is form of perfect square. Let me explain you what is perfect square. Perfect square is a formula a plus b whole square, which is equal to a square plus b square plus 2ab. So in this, a square is the square of first term, which is a, and b square is the square of second term, and 2ab is the multiplication of both the terms into 2 or to double it. For example, if our expression is like this, x square plus 4x plus 4. So in these types of questions, I told you first you have to apply the step to take common. So in this, you will see that nothing can be taken common. Second, pairs or groups. So we can't make a pair because there are 3 terms and can't be make a pair. So in these types of question, we apply the rule of perfect square. First, we have to recognize a square. So we have 1 square, so we'll write it a square. Then we'll find b square in the question. B square, if you carefully see, 4 is the square of 2. So this we can write b square. Now we have to find 2ab in the question. 4x. I told you that 2ab is the multiplication of both the steps, both the terms, and to double it. So if we multiply 2 into x, we get 2x, and if we double it, then we'll get, if we double it, then we'll get 4x. So 4x also available. So we can say that it is the form of perfect square. Now to make it more simpler, we can write it like this: x square plus 2 square plus 4x. Now this is a square, b square, 2ab. So we'll write it as x plus 2 whole square. So this is perfect square. This is our answer. Second example. Second example is little bit harder. This we can also write down. Like a square minus or plus 2 plus 1 upon a square. Now I told you that first we have to apply the step to take common. Nothing can be taken common. Second, pairs or groups. We can't make pairs. Third, form of perfect square. In this we have to find a square. So a square is available. This we can recognize as a square. Then we have to find b square in the question. So if you carefully see, 1 square of 1 will remain 1. So we can write it, this we can write it as 1 upon a whole square, because a square of a is available and we know that square of 1 will remain 1. So this can be written as like this. So we have square, or we have second square also. We'll recognize it as b square. Now we have to find 2ab in the question. So I told you that 2ab is the multiplication of both the terms and to double it. So if you multiply a, 1a into a, then we get a, then we'll double it. If we double it, we get 2. 2 also available. So we can say that it is in the form of perfect square. So to write it more simpler, we can write it like a square plus 1 upon a whole square plus 2. Now we can write it like in this form: a plus 1 upon a whole square, and this is our answer. Now our fourth step is differential square form. So what is differential square? Differential square is a formula: a square minus b square, which is in simple form is written as a plus b into a minus b. And in this step you have to see in the question that there are two squares or not, and if the squares are already given, so no tension. But if the squares are not given, then you have to understand the terms and see that can we make the square with the given terms. For example, if our expression is like this: 4x square minus 25. So the square of variable is given, but we are not given the coefficient. Square of coefficient is not given. So we know that this 4 is the square of 2. 4 is the square of 2. And 25 is the square of 5. Okay. Now we can recognize it as a square and this is b square. Now we can write it in this form. So to make it more simpler, we can write it as whole square, 2x whole square minus 5 square. Now we have 2 square and we can write it in this form. So we'll write it as 2x plus 5, then bracket close, into first term a, first term 2x minus 5, and this is our answer. Second example. Second example is this: a plus b whole square minus 1. Now how many terms are there? There are 2 terms, 1 and 2. Now you will say that there is a plus sign, so how can be there 2 terms? I have said how many terms are there in the expression. I am not saying that how many terms are there in the bracket. So if we put a bracket, then it will be a 1 term only. So this is 1 term, this is another term. So the 1 square is given, so we'll recognize it as a square. Then another square is not given. So we know that the square of 1 remains 1, because 1 into 1 is equal to 1. So we can say that b square also given. Now we can write it in this form: a plus b whole square minus this 1 term a square, then 1 square, this is another term b square. Now we can write it in this form: a plus b, then we'll put a plus sign, 1 into a plus b. This is 1 term, okay, this is 1 term. Then we'll put a minus sign, then another term, 1. This is our answer. I hope you understand till step number 4. So let us move to our 5th step, which is form of ax square plus bx plus c. So why do we use it? We use it when if our 4th step, 4 earlier steps which I have told you gets failed or we can't apply them. And there are 2 important things which you must know. First is recognizing procedure and second is way of solving it. So let us move to our first important thing, which is recognizing procedure. So we have 3 terms in this question. This is our first term, second term, and we have our third term here. So in these types of question, the variable of first term, which is x square, the variable of first term has full power. And in second term also the variable is same, but the power gets half. How it gets half? We can write it bx raised to the power 1. And because half of 2 is 1, so if we do x raised to the power 1 means x, so that's why we don't write 1 power. So in the second term the power gets half, and in the third term power gets 0. How? The variable is same, x raised to the power 0, and 0 power means 1, and if we multiply c by 1, what we'll get? We'll get C, which is same. That's why we don't write this much and we write only C. So in the third term we have 0 power. So this is our recognizing procedure. Now second important thing is way of solving it. So I am writing the question once again. Now in these types of question, what you have to do, you have to multiply the coefficient of variable of the first term and the third term. You have to multiply both of them. Then what you have to do, when you multiply both of them, the product, if you get the product is x, then you will make factors of x. Like factors are y into z. Then you will take such factors of which sum or difference is equal to the coefficient of variable of the second term. Okay, so I am repeating both the important things once again. First is the recognizing procedure. In these types of question, the first term has full power, x has full power. Then in the second term, variable is same, but the power gets half. How it gets half? Half of 2 is 1. And to write power 1 means x, because it means same. So that's why we don't write x raised to the power 1. And in the third term, the power gets 0. How it gets 0? I have told you. Then our second important thing is way of solving it. So first what we have to do, you have to multiply the coefficient of first term into the third term, and you have to make such factors of the product which you add or subtract. It gets same to the coefficient of variable of the second term. For example, let me clean the board. For example, first example, if our expression is like this, a square plus 7a plus 12. So what we'll do, we'll apply the 4 steps which I have told you earlier. First, to take common, nothing can be taken common in the expression. Second, make pairs and they'll take common. So we can't make pairs. Third, form of perfect square. So it is not in form of perfect square. Then fourth step I told you, differential square form. So it is not in the differential square form. Then at fifth step I have told you ax square plus bx plus c. So it is in this form. But ax square, so if a variable has no coefficient, so we will say that its coefficient is 1. So I have told you way of procedure. What we'll do, we'll multiply the coefficient of the first term and the third term. So we multiply 1 into 12. What we'll get? We get 12 answer. Then we'll make factors. Such factors that if we add or subtract, the answer gets similar to 7. So first factor of 12 is 2 into 6. So if we 2 into 6, I have written 16. So if we add both of them, we get 8. And if we subtract 2 from 6, we get 4. So it is not similar to 7. Then our second factor is 3 into 4. So if we add them, we get 7. So these are factors. Now what we'll do, we'll write a square plus 3a plus, we have add both of them, 4a plus 12. Then we'll apply the 4 steps. What are the 4 steps to take common? So we can't take anything common in the full statement. Then we'll make pairs. So if you carefully see, we can make pairs. This is one pair and this is another pair. So in this pair, what can we take in common? A can be taken common. So if we have taken A as common, so what we left? Here A will left, and here we have taken A as common, so here 3 will left. Then in the second group, we will take something common. So 4 can be taken common. So we have taken 4 as common. Here A will left, and if we divide 12 by 4, what we get? We get 3. Then we have two terms. So A plus 3 and A plus 3 can be taken common. A plus 3 we have taken common. Then we'll put a bracket. And from the first group, what is left? A is left. So we write A here. And in the second group, plus 4 is left. So we'll write plus 4 here. And this is our answer. We can take second example also. Now our expression is like this: x square minus 5x minus 50. This is our second example. So I have told you first you have to apply the 4 steps which I have told you to take common. Nothing can be taken common. Then we'll make pairs. We can't make pairs. Then our third step I have told you, perfect square. So it is not in the perfect square form. Then fourth step I told you, differential square form. It is not in the differential square form. But fifth step, form of ax square plus bx plus c. It is in this form. So ax square I have told you, if a variable has no coefficient, so we will say that 1 is the coefficient. Now I have told you the way of solution. So what you will do, you will multiply the coefficient of the variable of the first term and the third term. So if we multiply 1 into 50, what we will get? 50. Then we will make factors of the product. Our product is 50. So if we make factors, first we'll make small factors. So the smallest factor is 2 into 25. So if we add both of them, we get 27, and if we subtract, we get 23. Then our next factor is 5 into 10. So if we add, we get 15, and if we subtract 5 from 10, what we get? We get 5, and 5 is our coefficient. So we can say that these are factors. We will copy it as it is, and now here we have to subtract them. So we will put a minus sign, then we will put a plus sign, because if we combine minus and plus, what we get? We get minus. Minus means subtraction. Minus 50. Then we will apply the first step, which is take common. Nothing can be taken common. Then second step, make pairs or groups and then take common. So we can make pairs. This is one pair. This is another pair. Then in the first group, x is common. So we have taken x common. Here x is left, and here 10 minus 10 is left. In the second group, we can take plus 5 common. Here also x is left. X minus 10. Then we have two terms. So x minus 10 and x minus 10 is common. So we'll underline it that we have taken common. Then we'll take x minus 10 common. Then we'll put a bracket. Okay. Then from in the first pair, what is left? X is left. So we'll write x here. And in the second group, what is left? Plus 5 is left. So we'll write plus 5 here. And this is our answer. So I hope you understand this step and all the 4 earlier steps which I have told you. And if you follow these steps, I can guarantee no question will leave and you can attempt all questions. Please like and subscribe my channel and share it more and more so that everyone can know this. And thanks for watching.